Welcome to the Calculus, a collection of micro lectures, video lessons, and sample exercises. Let's apply the proven differentiation rules in computing the derivative of this given function. We can see here that in this given function, we have a product of two different functions. Hence, we are going to apply the already proven rule in differentiating product of functions. So we have here our function f of x is equal to the product of x to the power 4 and 3x minus 5. Let me redo the notation here because in our previously proven theorem, we used h of x to represent a product of two functions f and g. But since the given here is f, let me denote g of x being x to the power of 4 and h of x being equal to 3x minus 5. Hence, we can establish here that f of x is the product of g of x and h of x. The rule in differentiating product will use this idea that the derivative of the product is equal to the sum of two different scenarios. The first one is take the derivative of the first function times the original second function, and then plus take the derivative of the second function times the first function. So this could also be written alternately, as of course addition is commutative, so you could do things like that, or of course you can assign other letters for representing the functions. So generally we have this for our rule in differentiating a product. Hence, we already know the g of x in h of x as identified here earlier. What we need to do here is to give the independent derivatives of each. So for g prime of x, we have this. In short, we're going to use here the also proven differentiation rule for power. So we'll have here n times, n is 4, x to the power of n minus 1, but our n here is again 4. Hence, our derivative for g of x is 4x cubed. As for our h prime of x, you will have here 3x minus 5, so you will have here the product of sum. Again, don't be confused even if they are written in terms of difference, because you can have here 3x plus negative 5 for your general form of your h of x. Hence, we are still going to use here the sum. But basically, once you do it like that, you have here a constant multiple and a constant. And the derivative of a constant multiple will use the constant itself times the derivative using power of our x 1 minus 1 plus the derivative of the constant is actually 0. In short, our h prime of x, or a derivative of the second function h of x, is equal to 3. Okay, as x to the power of 0 is just equal to 1, so we will have here 3. Now that everything is complete, to give our final answer for the derivative of our given function, we simply plug in here the details. For your identified g prime of x, you have this one here, 4x cubed times your h of x, the original h of x, which is here, times 3x minus 5, plus your derivative of h of x, which is 3, times your g of x, which is x to the power of 4. As mentioned, since you can rewrite this alternately and even assign different letters for your functions, but in this case we are using g and h, then you can of course have different forms of this sum here, sum of both products. At the same time, okay, we can of course multiply now or simplify the necessary terms here. So you will have here by distributive property 12x to the power 4 minus 20x cubed, then plus 3x to the power 4 for the second. In short, the final answer here for a derivative of the given function, 12 minus 3, you will plus 3, that's 15, x to the power of 4 minus 20x cubed. This is the result for the derivative of this product of functions. Now, there are a lot of strategies that you could apply here. Others would, if they seem to think that the product of functions is a little bit more complicated to memorize or be familiarized with, they oftentimes multiply this Okay, so you will have f of x, which is also equal to 3x to the power of 5 minus 5x to the power of 4. This is also equal to f of x. And instead of using product of functions, you can use here simply the sum. So for this, you will have, of course, just derivative of f using this. Okay, just showing you other method which is also which also yield the same answer. So this is a constant multiple. So 3x to the we still have 5 times x to the power of 5 minus 1, and you have here minus, you have plus rather, you have negative 5. This is also constant multiple. You will have here 4 times x to the power of 4 minus 1, which will still give us 15x to the power of 4 negative 20x cubed. As you can see, both of them will yield the same answer, as you will use here the product or distribute here and use only the sum and difference. However, here's one important thing you need to really notice. If you would like to use this step, yes, the answer is still correct, but make sure that your distributive property or even FOIL method, if this is binomial expression, is correct in the first place. Because even if this result will yield to a certain answer, but in the first place this is not the correct equivalent of your product, then definitely your answer is incorrect. This is why most still would like to use the rule for differentiating product of functions, as this doesn't need distribution here, only at this point once you identify the necessary details. Thank you very much for watching. So what are you waiting for? Subscribe now.